The topic of nuclear power remains a controversial topic both here and abroad, with incidents such as those of Fukushima and Sellafield showing just how dangerous nuclear plants can be. The cleaning up of the Sellafield site involves people wearing full PPE and breathing apparatus going from room to room while they clear up mid to low-level nuclear waste. They can only spend a total of 90 minutes in each room for safety reasons, and indeed, some rooms have so much radiation in them humans cannot enter. So clearly, the cleaning and disposal of mid to low-level nuclear waste is slow, it's labour-intensive, and it's dangerous. The cost to the UK taxpayer of cleaning up Sellafield is approximately £2 billion a year. Now times that by 17, because that is how many nuclear sites the Nuclear Decommissioning Authority is looking to clean up safely and cost effectively. And that's where faculty and my project comes in. Faculty is working with a consortium to come up with a better solution to the disposal of mid to low level nuclear waste. Their proof of concept solution combines computer vision methods with AI. So how are they intending to do this? Well, there is a robotic arm that picks up an object from a pile of nuclear waste. Now this could be a battery, a cable, some concrete or rubble. And the robotic arm holds this item up to two cameras which take photos whilst that object is reorientated into several different positions. So where does the AI come in? Those images are fed into a neural network, and the neural network then tries to identify the object's type and its material. I worked with simulated data of various different objects held at various different angles, as you can see in the images on the slide, which shows images of a hammer, which is clearly made from wood and metal. Now, to design my neural network, I looked at various transfer learning models. Transfer learning models are models which have been trained on a very large data set, such as ImageNet, and that knowledge is then transferred to a smaller data set, such as the one that I was working with. I researched the following models: ConvNext, BGG, InceptionNet, EfficientNet, and ResNet. And it was found that the winning combination to get the best results was EfficientNet, followed by a multi-layer perceptron. So what does it do? EfficientNet takes in images and it learns the various features that make up that object in the image. For example, it learns the shape of a hammerhead's head and the shape of its body. And then the outcome is a probability vector for each image. It gives the probability of which class that object is most likely to belong to. So what were my results? Well, overall, the model was able to predict with a 74% accuracy the object's type, and an 82% accuracy the object's material. And indeed, the prediction accuracy is so good that the model can be extended to sort objects into recyclables and non-recyclables. So taking the example of my hammer, the model was able to predict with a 95% accuracy that the object in the image was a hammer, and 100% accuracy that this hammer was made from metal and wood. So what's the impact of all of this? Well, humans are exposed to less dangerous radiation, and the model will form part of a proof of concept solution, which will be presented at the end of the year to Innovate UK and representatives of nuclear power stations around the UK. The aim is to receive funding so that this model can be commercialised across the nuclear and non-nuclear markets with a production level solution. And finally, there is the aim to accelerate automation in general waste disposal, general construction, and domestic waste markets. Thank you very much for listening.